And the topics that we are going to cover in today's lecture include how to create and edit an ABB and how to add the move instructions in a program, and also use velocity and zones to control the program parameters. And I also will show how to debug the program. For example, we will execute the program step by step and move from one location to another location. And in the end of this program, so we can run the ABB program robot in using manual mode. So this is a very simple sample program. In this sample program, we are asking the robot pin to draw a rectangle shape. And once you learn this programming skills, you can use the simple programming skills to complete other kind of like complicated shapes. So this is the program structure inside the controller. All the program is named as, actually it is considered as the main module. So the main module, you can include the main program. It is saying it is proc main. So for example, the proc main, you see there inside the main program, you have routine 1 and a routine 2. But outside this main program, you see routine 1, it is after that, and the routine 2 also, it is a small kind of like short program, some program after routine 1. They are all located outside the main program. When the robot controller try to execute the program, it will first, follow routine 1. After finishing routine 1, we'll go to routine 2. And in the end, that is, you see, it is the end module. That is the match of the beginning of the main module. In the beginning of this main module, you see that's the data declarations. So all the data you use, like the tool data and also the position location in ABB robot, they call a position as a robot target. So that is the structure. And when you try to create a program, if there's no new program exist, so we need to go to the main menu. Here it is the main menu. And then we see it is a program editor over here. Click on the program editor. Now we go to this interface. Since there's no new program exist, so the next one we want to click, it is tab is new. So and tap the new. Once we have here, you are ready to add the instructions. And for example, you can add the move instruction. We can have the move J instruction, move L instruction. That is the program you see instruction on the left side. On the right side over here, that is, you can find all the robot ABB programs. Here it is the commonly used instructions. So for example, the move J instruction, you can call the routines and you can add some of the loops. So there's a move like a if and a logic sentence over here. So we will probably demonstrate it shortly, after we explain the basic things over here. So let's say we have the add instruction. We can jog robot into a position, and then we add the move J or move L functions. In this example, we have a move J. After move J, this is called a P home. This P home, that means the point. the target location. P20, same. Also, it is the location value. It is the target value over here. And you can name the position on your own. And you can name it by number sequence. You can add some like a meaningful name over here. How do you do it? And can you change the name position or the name of the position? Yes. Once you add a new location, normally that there is a asterisk. And if you want to change it to be a new name, you have to double click over here. Now you see this is the 3 dots. You know, once you see the 3 dots, that means you double click or you can make the change. So this is a letter button, so you can name this location or the position. And here we want to explain the 2 commonly used move function or move instruction. One, it is called a move J, another it is a move L. And which one you want to use? For move J, here it is move from a starting point to an end point, destination point, by using the quickest way. So this interpolation and can directly to move from the starting to the end. And with the closed path, robot can identify. You don't have to tell where you have to go and where you have to go through the path. And the robot will figure out on its own. And normally, when you see there's no collision or no any kind of like potential risk, or you can move from one fixture to another, can use and move J to save time. And for move L, that means it is a linear movement. This interpolation, it is the most accurate motion between the 2 points. So when you use move L, the robot will maintain a straight line. And then when we see, for example, the welding kind of like operation, you want the robot to move straightly along a line from one location to another, then you use the linear function or linear instruction. So that is the main difference. So, and then when you see the movie instruction, this is the basic structure. First, it is movie instruction. Either you choose the move J, move L, another it is move arc, move center, move circle. So after that, it is the location, P start, P location, that is the position. And then we see the V. V means velocity, how fast you want the robot arm to move. Zone, it is another parameter to kind of like will guide and figure out how close, how accurate you can approach to the end point. Then T means it is the tool you are going to use. So for example, and the instruction above means the robot is going to move to the location P start at a speed of 500 millimeter and with the zoom data of 5, and by using the tool T grip. So in order to change any of the parameters, for example, you can change the location to different point, and you can change the speed, you can change the zone, even can tool. Once you double click, you have the choice to make the change.
Okay, so now if we are talking about the zones, the zone is basically how close you want to go to your target point. So how precisely you want to approach your target point. Let's take the example of maybe you are doing some kind of welding operation. Then you want to make sure that you are reaching the target point exactly. Maybe you are just placing the robot tool at some location. You don't need to go as accurate as you would be going in the case of welding. So this is going to decide what zone you want to apply. Now you have various different zones starting from zone fine to zone 0, then you have zone 5, zone 20, 40, 50, so on. Zone fine is something like you want to go to the particular point and you want to stop for about half a second. Zone 0 is you want to go to the exact point, but you don't want to stop. Where do you use these things? Let's say, for example, you are going and then you are going to change the direction after approaching that particular point. Then we can use a zone fine because you want to go there, pause for like 0.5 seconds and then change the direction. Let's just suppose you are going in an arc. You don't want to change the direction. Then you can use zone 0. Maybe you are only just positioning the home position for the robot. You can go by like zone 50. One more important thing that I would like to add is the first time when you are adding the move location, if you are setting the velocity and the zone, the same zone and the velocity will be taken for all the subsequent move commands. That's an important thing, because if you forget to do it for the first move and then you realize after the 5th or 6th move command, then you'll have to change it for all the move commands that were already executed or were already given in your program. Okay, changing the data. How do you change the data? Let us suppose this is what you have, and now you want to change this zone from 50 to zone fine. Just double click on this thing and it will take you to the screen where you can change any of these values. You can change your destination. You can change the velocity with which you want to move. You can change the zone. Now, the velocity that you have here, if you are running it in the manual mode, no matter whatever velocity you give, it's going to be just 250, the maximum. And select the data that you want to input here, press OK, and then it will be executed. Modifying a position. How do you modify a position? Now, one simple way of doing this is you can actually start writing the program, because you know how many different points you will need. You can first just write the program and then you can teach the individual programs to the robot. How do you teach them? Let's say in this case, I want to teach P10 location. So I will just highlight this P10 location here, and then I will take my robot arm or the tool to the exact position using my joystick. Using my joystick, I will just place the robot arm where I want the tool to be, and then I will hit modify position. Once I hit modify position, whatever is the value here, that will be overwritten by the current location of the tool. So later on, if you want to again change the position, you can again do this, and then the old data will be lost, and then you will be replacing it with the current position of the robot tool. Tap on modify position. Okay, once you are done, and then you want to actually run the program. If you want to run the program, once you have added all the instructions and then you want to run the program, then you will go to the tab debug, and then we will go to pp to main, and then we will add it, and we will just run the program. This is the pp program pointer. Once you go to pp to main, you will be going to the beginning of your program, and then you can run your program. Another important thing in the robot system is checking the calibration. How do you check the calibration, as well as how do you do it? Today, we are only just going to see the theory of how to do it, but we will be actually seeing it in the lab demonstration, which you are going to have after this. So first of all, we are going to give move absolute J command. The move absolute J command will not be used in the program more than once. If you want to use the move absolute J, you are going to use it just once in the beginning. And then after that, you are going to use just the move J or the move L commands. Now, if you want to do the calibration, you are going to use only the move absolute J position. Insert the move absolute J position, click on the asterisk position, and then go to debug, the one that we saw just now. Go to the debug and hit on view value. Once you go to the view value, it's going to show you what is the value of each of the axis of all your 6 joints. Then what we need to do is whatever the value you have here, change them all to zeros and hit OK. Then it will self-align itself to the 0 positions, and then it will automatically calibrate all the different joints. You will be seeing this when we will show you the demonstration in the lab. Then you will be able to understand how to do this thing.
Okay, here it is the example of using the flex pendant and write a simple program. So here it is the main program. And in the main program, we first want to move to the home position. So teach your robot arm to at this location, you hit on change position, modify position. And and then look at over here, this one we use, it is move J. And here it is move J. And the next one, we go to P10. But P10, because that's the location on the floor, we are going to draw. So this is the kind of like a critical location or the accurate location you want to be. And then this is move L, following P20, 30, 40, and 50. After finish them all, we finish and go to the P60. So that is the end of the program. And just like Dr. Revu mentioned over here, and once you define the first instruction and pretty much all the velocity and the zoom and the true data over here, if you want to change, see here we have changed the zoom from 50 to 5, and the following, they are all the same kind of like that. So that you want to be careful when you write a real program on the own. After you have the first sentence, you want to pause a little bit to think about it. Do I need to change the V data or find or true or anything? Okay. So here is the stepping instructions, so we can perform a program by using the flex pendant. So basically, these are the 4 soft case we are going, to show you later on when we program this case. But when you debug the program, mainly it is use these 4 cases. So this is the run button. So once you hit over here, the program will start and execute from the last point to the end point. And this button, that is step-by-step function. So once you hit 1 time, and then you have to hit for all the steps, 1 sentence, another sentence, another sentence. And this one, it is stop the program. So the program will completely be stopped. So the next one, we want to talk about, after we finish the basic fundamental programming, and then we want to tell some detailed things we need to use or prepare before you write the program. And it is a tool definition, tool center system, tool coordinator system. Here it is the base coordinate system, but we want to use the tool coordinates and let the robot know how your tool, this center compared with your base coordinate. And that's the beginning, and you want to define, and then the controller will understand where the tool, how far it will compare with your base location. And the benefits of using the tool, it is, you can use the jogging or reorientation, and easy to change the tool. Because for different tools, they have different shape, geometry, and mass, and how heavy, and then they have different physical kind of like properties. So for each of the tool, now we need to define their like a tool coordinates. So these are the different tool types, tool shapes. So, and then in order to define a tool, I think there's something very important that is TCP defining a tool. So for example, here is the tool 1, and yeah, we use, but once you use a tool, you can name your tool for sure. So tool, click the 3 dots, you can name the tool. And here you want to make sure it is main module or user module. And then after that, you want to define your tool. Once you click the tool, and this is after the tool name, and then there is the one location, it is a click on define the tool. Once you go to this interface, you have to make sure the mass by default somehow the negative that they want to cause your attention, because it never can be a negative value, which means that you have to enter your own real mass value. So it should be a positive value over here. Okay, that's the tool, and give a tool name, and then have the initial like value, and it gives a mass, and also enter the weight of the tool kg. And also you need to use the cursor scroll down. There is a center of gravity. So you can give some like rough value of 1 or 2, 3, because eventually we can use a program to find or to identify what is the real kind of like center of location, or what is the real value of this like a mass function, or what is the weight of this tool. And this can be done automatically. So, and how to define a tool center point? There are multiple ways. Here it is the method. If you click down this drop-down menu, they give you options. But here we use the TCP and the Z method. And in this method, you are going to use like 4 points to define the tool center point. So choose the method TCP and Z, and then you will see 1, 2, 3, 4 points. We are going to jog the robot tool center to be different location to point 1, 2, 3. So, and once, and then at a different location. For example, if you move the cursor down to point 1, here will be highlighted. And then you can click on modify position. The robot will memorize this point. And then you go to the next point. It's going to modify position again. So you have to go through all the points, modify the position, repeat the 3 operations. And then the last point, it is make sure the tool, it is up straight up and down location, and then multiply this as the fourth position. And after finish all of the 1, 2, 3, 4 position, and we are going to just move the tool up at a 0 direction and about 1.5 inch. Since it is about 1.5 inch, not necessary to be exactly 1.5 inch, just to make sure it is above the fourth position, and then tap the modify position. Click on it. And here you can see the kind of like graph picture how to modify the defining a tool center point. And this is the tool we are center point. We want to use this as our reference to define this tool center point. And there are 3 locations, 1, 2, 3. So the third, actually, you see this is just the front view. You cannot see it clearly. And but this one probably is a little bit easier for you to see. And that is position 1. And make sure you modify position. Here it is another location, position 2, and then position 3. All the 3 locations, 1, 2, 3, they are not straight up and down. So we have to each modify the position and memorize them. And for the last position, that is position 4. So this should be up and down, but also touching the close as possible to reach your reference point. And then you want to increase the tool up about 1 inch or 1.5 inch. So the distance is not accurate. And then once we remember all of the location, and the robot will actually measure and figure out or calibrate where it is your tool center point. So, and this, it is the final result showing your tool center point and reach to your reference point, the maximum error. Now it is 0.65 millimeter. The minimum error, you are doing this process, it is 0.23 millimeter. And then the mean error is 0.45 millimeter. So this page only will let you see one time. Okay. After you define this tool, you click OK, this page will disappear. And for industry or production purpose, maximum error should be reaching to 0.5, I think. And for educational purpose, the maximum error probably it is 2.0 millimeter. So and so the production actually maximum error should be 1.0 millimeter. So that means the production you want to be reaching to the higher requirement. So that is the tool definition. How do you define a tool center point? So just when you define the tool, you have to enter tool map. We don't know exactly, but as we said, it doesn't matter because we can use we call it is a load identification, this kind of like a routine. This is a service routine to find out exactly what is your tool weight and the tool load, even can find out what is the center of gravity. And what is the load? Here it is the arm load. And this is the tool load, and here it is payload. And for the this service routine is to try to find out the load, tool load. and how can you do it? So we need to, before we define a tool load, first make sure and to check. And now you are using the exactly tool you want to measure, okay? Not necessary to be tool 0. Maybe it's your own tool, tool 1, tool 3, tool pin, tool whatever. And then you are going to call this, it is in the main like program, you need to move absolute J. So, and then we want to call this, it is called the routine. This routine, it is load identification. There are quite a few steps. Here we have the PowerPoint slides that show you the procedures, but actually we need to use the lab demonstration to show you how to do it. So we cannot, explain this. Even we explain or repeat or kind of like talk about it over here, actually we will not give you, a good kind of like teaching effectiveness. We think we should better to do it in the lab demonstration. But I want to show you after you run the program. So, and we can see what is the result. So here, and you see the result is after we run this service routine and the robot controller will identify the result of the tool identification. For example, here, the mass is 2 kg. And as the center of gravity, they found out is X0, Y0, Z0. They ask you, do you want to update the tool information to your data? You say yes, we want to update the tool data. So here it is the tool center definition.
Okay, so we'll be seeing about assigning the outputs later when we are actually doing the programming, especially with the if-else loops, then we'll see this thing. Now, let us see the work objects. The work objects, like we have discussed in the previous lecture, the work object is specific to the work platform that you have for each product. So now, let us suppose you want to do the same work, you want to just replicate the same process on 2 or 3 different fixtures. Then we can assign a work object to each of these fixtures, and then we can run the same program on these. So let us see how we can define. Like we saw in the previous slides, you have the base axis system or the base coordinate system, then you have the tool coordinate system, and this is the work object coordinate system. Okay, let us see how we can create this. We will be going to the main menu first, and then under the main menu, you will be clicking the program data. Once you go to the program data, then you have the work object WOBJ, and then once you hit this, you'll be coming to the screen. Here it will ask you what kind of object method you want. We will be selecting the 3-point object method. And now, before you start defining the work object, it is important that you have a paper on your platform wherever you want to define it, or at least the reference points. And then you will need to identify 2 points on the x-axis, 1 axis, any axis you can take as the x-axis, and the perpendicular axis should be the y-axis as per your own designation, as per your own requirement. Now, here we are going to define the axis system using x1, x2, and then y1. That is 2 points on the x-axis and then 1 point on the y-axis. Remember, once we know the x and the y-axis, we can define the z-axis automatically by using the right-hand thumb rule. So here what we are going to do, first we are going to position the tool at x1 and then hit modify position. Then we will again position this to the x2, hit modify position, and then position it to the y1 and then hit modify position. So once you have created your own work object as well as the tool that you want to use, then you will go to quick set menu here, quick set button, and then you will go to the manipulator. Once you go to the manipulator, you can select what tool you want to assign to the manipulator as well as what work object you want to assign to your manipulator or the robot. Okay, let us see what is the use of using this work object. Okay, I have now defined this work object here, maybe with my x1, x2, and then y1. And then I have used a simple program to draw this triangle. Now, if I want to use the same program at a different location, I don't need to again redefine all these points. I don't need to again teach all these points. Instead, I can just redefine my work object system using the new x axis and the y axis for the new location. And then I can just run the same program again. This we will be demonstrating it to you when we are doing it in the lab. Let us see about structured programming. What do we mean by the structured programming? We have already seen some kinds of programming where we saw the move J as well as move L commands. So what is so different between the structured programming and the other one? In the structured programming, the most important thing is we are going to add the input-output instructions. We are going to assign the programmable keys to various different outputs, as well as we are also going to add routines to the program. So before running the program or before starting the program, first make sure that your robot is calibrated and then have a good TCP work object system. Plan your programming before starting it. So plan how many points you need, what points you need as your target positions, and what points need to be reached by using move J, what points by using move L. Plan all these things before we actually start writing the program. Okay, today we are also going to see about some input instructions like the set, reset. What do we mean by set, do, pulse do, invert do, and all these things. Set, for example, turns on an input and then it just leaves it on. One of the most common applications of this set and the reset will be for your gripper. You want to open the gripper, we use reset. You want to hold something with the gripper, we use set. Similarly, if you want to have pulse do is once it will be on, the next cycle it will be off, then again on, then again off. So each of these things will be used in the programming. Then we also have the wait instructions. Like for example, you need to wait at a particular position until you get an input. Remember, like we have talked in the previous lecture, input doesn't mean the input that you are giving to your programmable keys, but it is the input that you are going to receive from maybe an external robot or maybe an AGV, something else. Or maybe you want to wait until a particular condition has been satisfied. Maybe you want to wait until you get 3 objects or 3 parts of your product and then pick them all up together. So you want to wait until some particular condition has been satisfied. Or maybe just you want to wait for like 0.5 seconds, 1 second before carrying out the next instruction. So this is what I was saying. Hit set, then we will go for the gripper. Usually we will use this for holding an object with the gripper, releasing the gripper using the set as well as the reset commands. Now, where do you have these commands? These commands will also be in the same add instruction tab, but they may not be under the most common tab. So you may have to just go down using this drop down menu and then you will be seeing all of them. Or you can just use the previous and the next buttons to move to the next set or the previous set of your commands. Then timing. Do you want to like stop for a minute? I mean, stop for like 1 second or like 2 seconds, what you want to do. And also the timing depends on the zone, especially if you are using the fine zone, then the gripper will automatically stop there for like about 0.5 seconds before doing any other instruction. If it is not a fine zone, then you won't stop. You will just automatically continue the sequence of instructions. So this is the fine zone, and it just hesitates for like half a second. Okay, structured programming. Jackson structured programming uses basically the subroutines or the routines. The routines are like subprograms that we use in the CNC machining. So here, when do you want to use the routines? You want to use the routines, especially if you are doing any kind of repetitive actions. If you are doing the same operation again and again, then you want to use a routine instead of writing the same set of instructions every time. This will clean up the program, make it more readable, and then make it more compact. Or maybe you can just break down the instructions, or like break down your entire program into small separate parts which can be easily separated. And then if you want to use, let us say you want to use logic, if something happens, pick from bin 1, or maybe something else happens, pick your raw material from bin 2. So for all these things, it will be easier if you are using a routine. If you are not using a routine, you will have to write the same set of instructions each and every time for each and every condition. So here in this example, you can see you have the main program, and then you have the routine for pickup, routine for square, routine for drop off. Now, there is no hard and fast rule that you should use R before it, but using R before the actual name gives you an indication that it's a routine, and it always helps you to write the program. So how do we create the routine? When we are creating the routine, we should go to the main menu. Under the main menu, you are going to program editor, and then in the file, you are going to go for creating a new routine. So we'll go to the routines, and under the routines, we are going to create a new routine. Once you just hit create a new routine, then you can change the name as you want. All the routines will be in the main module. You will just change the name as you want, and you will have them. Let's say in this case, it is R feeder _1. That's the name of your program, of your routine, sorry. Then once you are in the main program, then you will call the routine. How do you call the routine? So if you go to the add instructions tab, you will have a command called proc call. When you go to the proc call, it will show you all the list of routines that you can select from. So you are going to select, hit proc call, select what routine you want to have here. And then at the end of all these routines, you are going to use the return button. So once you use the return button, after executing all the routines, it will just send the program pointer back to the main program. Or if you are inside a routine, it will just send it to the top of the routine. So in this case here, if you see, you have like two different feeders. You have two different feeders, and you have a lathe, and then you have a conveyor. Let us just take this as an example. So you are going to select from maybe feeder 1, bring it to the lathe, process it in the lathe, and then place it in the conveyor. If some other condition is satisfied, maybe you want to grab the part or grab your raw material from in feeder 2, and then you want to use it. So this is a sample program. We will be seeing the actual program when we are writing, when we are doing it in the lab. You'll be able to see how we can introduce the if else loops, and then how we can actually do the what you call routines, call each routine based on the instructions. So let us see about the what you say, the flow of your program here. So coming to the flow, first we have the main program, and before running the main program, of course, we are going to calibrate it. And then once we have the main program, maybe you have the housekeeping, which will happen irrespective of your conditions. And then you have the lathe conveyor. So all these are like the different routines that you want to use, and you want to call them each time when you are running the program. So decision making is extremely important when you are writing the program, as well as when you are using it. So maybe if something happens, or if some particular output is generated, input or output, whatever it is, then go for the feeder 1, else do something else. So how do we do these things? So you are going to add the if loop, then you can add else if loop, then you can add an else loop. You can add any number of else if loops, but of course, else loop is only one, because if all the above conditions are not satisfied, then you will have else. So it's going to be only just one single else for your command, but you can have one if, one else, and then you can have any number of else if loops that you want to add. So you will go to the add instructions and you will hit if. Once you hit if, this is what you're. Now, please don't enter anything here. Double click on this if, and then it will take you to the screen where you can add else if, or you can add else, or you can add multiple else ifs, and then you can just add your else loop here. Then you will hit OK. So then you will have multiple loops, if else loops inbuilt in your command. Now, then you will go to the first expression. Then you will go to the first expression, and then here you are going to insert the condition. What condition you want to be in here. So what condition should be satisfied for this particular instruction to be completed, or this particular operation to be completed. So first you are going to select whether you want to go with an input or you want to go with an output, what you want to do, and then you are going to give what signal you want to use. So here, how do we do this? Double click on this EXP and it will take you to this screen. Here you will change the data type, whether you want to go with a digital input or you want to go with digital output, what you want to go here. Then once that comes into picture, then you can select the expression by just clicking this plus sign, whether you want to go with a 0 or you want to go with an equal to, or you want to go with less than, greater than, what kind of symbol you want to use. And then let's say I'm using equal to, and then I will select this EXP and then hit only selected. Edit, only selected. If I hit edit all, the entire expression is going to be edited. But I want to change only this thing here to write my condition. Maybe di1 underscore style 1 is equal to 0, or maybe is equal to 1. I want to execute some particular operation. Maybe 1. I will just hit OK. So I'm going to execute that particular operation. Similarly, for else if I'm going to do the same thing as well as for else. We will be showing you all these things when we are doing the demonstration in the lab. There we will be showing you what are the different conditions, and then how to do these things. Now, if it is an input, it has to come from an external robot. But if it is an output, then we can assign a particular output to the programmable keys that we have using the control panel that will show you how to do it, and then you can execute. Similarly, if you want to have the wait until, or maybe you want to wait until this particular thing is equal to 1, or maybe you want to execute a wait 0. So you can introduce the conditions here. You can introduce what input you want to have, and then you can go for what time you want to use, or maybe a time flag, whatever you want to see until this particular condition is satisfied. So this is a sample program. We won't be doing this exact program in the lab, but we will be trying to do a similar program, a more simpler one without so many kinds of commands, and then we will be demonstrating it to you.
So the next one topic, it is working with numbers. So the working with numbers, it is very, closely tied together with if conditions. And the only difference is we will set up the condition by using a number. Number, it is the count. So that is the special data you need to define and in the beginning of the program. It is the variable type of data, and but it is designated as an n before the name. So we can use n count and n parts, how many parts, n circles, and then we can sign this number. The operation, for example, we want the robot to pick up the parts, and every time if it started with 0, we can assign a specific count number started with 0. After complete one operation, pick one part, you can increase the number to be counted to be 1. And another time, you can continuously increase to 2. So we can give a condition such as, so if the n count less than 3 or equals to 3, we can switch to another kind of like type of parts. So this is how you use the count. And for the count, you can use increase or decrease, and also you can use clear. That means so. And but normally in our example, we are going to show you it is we started with 0, and then we are going to add another one. So when you add this function, add this count variable, so this is a normal kind of like a mathematical writing. But in ABB language, they use it is INC, right? INCR and count. And so that is the examples. If you want to clear this number, you can use clear and count, and also use add and count. But in our conditions, we use, I think in our simple example, we are going to demonstrate that we use INCR, excuse me. Remember, and to create the data before you start with the instruction. That's why we said in the beginning we need to define the count with variable. So it is in the demonstration. I think it is in the main program. Main menu, and then there is a location you can find out the data, you can find out the count. So we'll do this in the lab demonstration. That might be easier for us to explain. And for today, we pretty much finish all of our kind of like topics. And thank you.